couple of hits, as you know. Maybe other stuff too. All right. I might let you do it harder. Come on. All right, here we go. So I have absolutely nothing new to teach you today, which is kind of nice. We're going to be putting together all of our skills, our synthetic division, our analyzing the graph to get an answer. We might be doing some factoring. It's kind of a free-for-all here on what skills we're going to use. I might have to use quadratic formula or completing the square. It's just a little bit of everything. And we might have some imaginary answers coming at us again too, where you have the square root of a negative. So nothing really new to teach you, just putting together all of the skills. So we are doing 3.5 today. It's called the Fundamental Theorem of Algebra. Sounds super fancy, but it's really not, and you really already know it. So if f of x is a polynomial, degree n is greater than 0, then f has at least 1 0 in the complex number system. Now, as always, these are so wordy. You already know this. I've already been teaching this to you. The fundamental theorem of algebra, how whatever the degree is, the fourth degree, there should be 4 answers. Third degree, 3 answers. The degree equals the number of solutions. You know that. So we're just still practicing on finding all of those solutions, depending on what we have to do for skills. Now, same thing is this complete factorization theorem. It's really the same thing. However, whatever the degree is also the number of factors. If you have a 4th degree, you have 4 solutions and 4 factors. So the degree also equals the number of factors. And remember, you can see here they're written down in factor form. If your solution is x equals 7, your factor, of course, x minus 7. All stuff that we have seen, we know, we've done it. Okay? It's a little bit of everything. Now, like I said, we're going to see more imaginary answers come into play today. You have done imaginaries. Square roots of negative numbers kicks us into the imaginary unit system. So let's talk complex zeros. So the nice thing about the complex zeros, I kind of think of them as a 2 for the price of 1. You always have 2 imaginaries. You will always have the conjugate. So if you know a plus bi is a 0, you automatically have a minus bi is also going to be a 0. So the imaginaries always work in pairs. You always have 2 of the imaginaries. All right, now, to try to give you some guidance on how to find the zeros. And again, we're using all the things today, all of the skills today. Personally, you've seen how slow I type on the calculator. We don't need to judge it. Personally, I always try to factor first. I'm very fast at factoring. I can take a GCF out. I can figure out what multiplies and adds. I always try factoring first. Like I said, I just happen to be quick at factoring. That's how I roll. Now, if you're like, oh man, you can't see that it's going to factor, it doesn't factor, you can't make it work out, then we're going to take a look at the graph. So if you cannot factor, so if the factoring's not doing it for you, take a look at the graph. And you should be able to get at least 1 0. Now remember, 0, solution, x-intercept, you should have 1 nice answer. I'm not saying they're all nice, but you should have 1 nice answer at least per problem. And then of course you can take that and do your synthetic division and work on it from there. And again, it just depends on the problem. I might have to use quadratic formula. I might complete the square on it. Everyone's a little bit different. So we're going to try some different things today, look at some different problems. That's really what we're going to be working on today, is finding all the zeros. So I want all the reals, all the imaginaries. It's a 5th degree. I better have 5 answers written down. All right, let's do it. Find all the zeros and all the factors. And you'll see on your test, I always ask for all the zeros, all the factors. So first thing that's popping up into my head, I'm like, okay, 3rd degree. I need 3 total answers. So I got a couple choices right now. Luckily, we don't have to do like last week and list all the possibilities and guess and check on synthetic, okay? I'm quick at factoring, so I'm going to look and see if it might factor. If I'm not seeing that it's going to factor, I can't figure out the factoring, then I'm going to go to my graphing calculator, which I have ready to pull up too. So let's first talk about, do you think it's going to factor? So I hear one no. If you don't think it's going to factor, let's go to the graph. So I'm going to type it in. Lord only knows what I have in here from other stuff. X cubed. Don't judge my slow typing. And remember, we should have at least one nice answer. So it looks like we're touching the x-axis there at 3. I'm going to do a little table check just to make sure. 3, 0 is one of the answers, so I feel good about it. So I'm just going to write down x equals 3 here for a second. Now, that is only one of the answers. We need 2 more. So I'm going to take 3 and do my synthetic division. Now, just like last week, as always, just a reminder, make sure your terms are in the correct order. And if you're missing anything, throw that 0 in to hold the place. As long as we don't mess up, we should have a 0 remainder here. 3 times 1, add 3 times 0, add 3 times 1. Looking good. So I'm going to recover this. I have 1x squared. I'm not writing 0x plus 1. So my other 2 imaginary answers are going to come out of this. I'm going to set it equal to 0. Now I'm looking at this. It's not going to factor for me. I'm just going to make it easy. To get x alone, I'm just going to use inverse operations. I'm going to subtract 1 over, and then I'm going to root it. What is the square root of -1? Plus or minus I, yeah. There's my 2 imaginaries. So I do have all 3 answers. And I'm going to write out the factors for you here in just a second, because I need to do that for you. Now, some of you, because I thought I heard some mumblings back there, some of you might have looked at this. Did you try to factor it by grouping? It does group. If I want to group it, I can take x squared out of the front, a 1 out of the back, just to show you. You put the 1 there for dramatic emphasis. And you're going to end up getting the same answers. So of course, here's the 3. If I set this equal to 0, I get the plus or minus I. So multiple ways to approach these problems today. One's not better than the other. It just is a matter of, did you see the factoring or did you not? If you don't see the factoring, you're on the graph and you're doing synthetic division. Okay. Final, I need the factors. I was going to write f of x. It's p of x over there. All right, so 3 is one of our answers. I'm going to write it factor form. Positive I is a factor. I'm going to write it negative I, and then plus I. And you will see too, especially if you start to run out of room ever, because sometimes I start to run out of room, like this gets a little obnoxious with the plus or minus. If you ever want to just, I say combo it, you could make it plus minus I in factor form. Just recognize that's really 2 factors for the price of 1 there. I don't care if you do it or not. Sometimes I run out of room and I kind of have to. So I'm going to kind of circle both from my factors. So 2 different methods, we get the same answers. It just depends on if you saw that factoring or you did not. This is what we're doing today. All right. First question, how many answers are we after? 3. So I'm fast with factoring. I always check it, but I'm like, A, nothing multiplies to 4 and adds to -2. And B, it's weird because you have the cube, then the x. So I'm not going to try factor. Let's go to the calculator. So graph it. Let's punch it in our calculator. Let's not judge how slow I type on it. And let's find where it hits the x-axis. Plus 4. Good graph. Okay, so it looks like at -2. I'm just going to verify on the table. You know, I like to be dramatic. Let me scroll it up. Yep, -2 looks like a win. Okay, so let's jot that down. X equals -2. So we have one of the answers. I need 2 more. So it only hit your x-axis once, of course, so I know the other 2 are going to be imaginaries. There's going to be i's coming at us. And of course, I can't factor, so I'm going to use synthetic division now. And be conscientious, you don't have the squared term. Don't forget the 0. All right, we should get a 0 remainder. Of course, something bad has happened here. Negative 2 times 1, add those together. Negative 2 times negative 2, add it up. Negative 2 times 2. All right, I'm going to recover this polynomial. I'm down to 1x squared minus 2x plus 2. So my other two, and I already know they're imaginary because my graph only touched the x-axis once. So the one real answer, I know the other two are imaginary, are coming out of this. So I'm going to set it to 0. Of course it doesn't factor, they're imaginary, and nothing multiplies to 2 and adds to negative 2. So now you have to decide. Do you want to complete the square or use quadratic formula? Don't care. We're all going to get the same answers. Personally, I think this is a good completing the square one because you can do half a b in your head pretty fast. So I'm going to subtract the 2 over and get it out of the way for right now. And I'm going to recalculate this third term so I can force it to factor. So half of 2, 1 squared 1. And of course, I'm going to balance and put that on the other side. Now, the blue 1, like I said, forces the left side to factor. Multiply to 1, add to negative 2, negative 1, negative 1. And I'm going to add negative 2 plus 1 together. I'm going to get rid of squaring with the root. There's the imaginary coming at us, plus or minus I. And then last thing I'm going to do to get x alone is just add 1 over. So I have all 3 answers. Negative 2, my one real off the calculator, my other 2 imaginary. Now it also, remember in the directions, it wants all the zeros and all the factors, so I'm also going to quick jot down factor form. So my first answer was negative 2, so factor form x plus 2. Clearly I'm running out of room. You might be 2, so I'm going to combo this. I'm not going to split it out into 2 separate ones. To get positive 1, I need negative 1 in a factor, and then just plus or minus I, because I'm running out of room. So it's just a variety of skills on this one. You could have used quadratic formula here, you'll get the same thing. So don't freak out if your work is different than maybe mine. The final answers will all be the same. Love it, nothing new, just putting it all together. Okay, so this you know, but again, you're going to start seeing, they're going to start using the word multiplicity in here. So in our complete factorization, zeros don't all have to be different numbers. You could have a multiplicity. Just like in this polynomial, we have seen these crazy multiplicities. Of course, quantity cubed, there's 3 of those, 2 of the x plus 2's, so on and so forth. So you'll see these little notes behind that might say the word multiplicity in it. So that's what it's talking about. The zeros theorem, that's really the same thing. Every polynomial has exactly n zeros. Duh, 4th degree has 4 zeros, we know that, provided the 0 is counted k times. So that's just meaning, remember last week I was so nitpicky, I'm like, you have to list all the zeros when we were sketching the graphs. Even if you had a double, you had a repeated one. I needed you to list that repeated one because we knew it would touch the x-axis versus cross it. That's why it's important to list all the zeros when we're looking at the graphs. Stuff you know. All right, find the complete factorization and all the zeros. It's more of the same. This is nothing new. So you can decide, take a look at it. Do we want to try to factor it or do we want to go to the calculator? What's our thoughts on it? I would, before I do anything maybe, because I'm quicker at factoring, I might set it to 0 and I'm going to try to pull a GCF out and look at smaller numbers. So I'm going to try to find all the zeros here. I feel like I can factor. We got some big numbers. I'm going to pull a 3x out. So I'm going to need x to the 4th, 3 times 8, and then 3 times 16 is 48. And I'm like, oh, heck yeah, I could factor on this. I can break this trinomial down more. What multiplies to 16 and adds to 8? 4, yeah. Okay, so we get 16, of course, 4 and 4, or our numbers multiply to 16, add to 8. And because your lead term is x to the 4th, we just have to bump these up to squares. Now, if you're like, man, there is no way I would have seen the factoring, graph it, get a 0, do synthetic division. You'll get the exact same answers. Now, 5th degree, here we go. I need to get 5 answers out of this. Well, first I'm going to set 3x equal to 0. I can solve that in my head. Divide by 3x is 0. I'm going to set x squared plus 4 to 0, and let's just get real about it. I'm just going to copy the answers down for this one too. Okay, so I'm going to subtract 4, and I'm going to root it. Well, what's the square root of negative 4? Plus or minus 2i. And because this is the same factor, clearly I'm not going to do all the work again. I'm just going to copy that down. So do I have all 5 answers in front of me? Count them. 1, 2, 3, 4, 5. Bam, got it. And we have to, of course, because it wants all the factors. Okay, we're going to have factor form. Clearly, I'm going to use some plus or minus because I'm running out of room. Okay, so my first factor, of course, is the 0. So I'm just going to use x minus 0. You can even keep the 3x if you want. Plus or minus 2i. And if you're really running out of room, I could just throw a what on this? Squared. If you're really running out of room, since we had that double there, or you could put x plus 2i again. Really depends what you have for room. Now, seeing what the answers are, okay, you could have graphed this. It would have hit your x-axis right there at 0. It seems weird, but you can do your synthetic division with 0 and work on it, and you can solve it, and you'll have the same answer. Choices today. I just was like, man, big numbers right away. I was like, I want to take a GCF out because I think it's going to make it easier on me. Okay, so let's look at this guy. I'm going to set it to 0. I need 4 answers, 4th degree. I'm already thinking factoring because you know I'm quick with it. I think we can make the numbers work. What multiplies to 100 and adds to 29? Yeah, 25 and 4. And of course, to FOIL back out to x to the 4th, I'm going to have to make this x squared x squared. So I'm just going to set each factor to 0 and solve for x. So I would just use some inverse operations here. I would subtract 25 and root it. We'll do that in a second. I'm going to do the same on x squared plus 4. Because those can't factor down any further. If this was minus 25, then I could factor it down, but it's not, so I can't. So I'm going to subtract 25, root it. What is the square root of negative 25? 5i. So there's 2 answers, halfway. Let's subtract 4 over and root it. What's the square root of negative 4? Plus or minus 2i, good. Now, and I know I got to write out all the factors, I'll do it in a second, but looking at your answers, would have the graph helped you at all? No, the graph wouldn't have done anything for me because all of the answers are imaginary. So if you graph it, it does not touch the x-axis. I mean, I guess the graph would tell you they're all imaginary and you'd have to figure out an algebraic method. But the graph, not going to do it for me this time. All right, last thing, just wants the factors. Clearly, probably space is an issue. I'm going to combo it, plus or minus 5i, x plus or minus 2i. And, you know, if you're bored and just the love of math overwhelms you, if you FOIL all that stuff out together, you'll get the original problem back if you want to check it. Yeah. Nobody's going to do it, right? Okay. Any questions on that one? I see people writing, so I'm just going to wait a second. All right, let's look at the next one. I'm excited for that one because we need how many answers? 6. One of the bigger ones of the day. Usually 3 and 4 is kind of the common. We're getting wild here. So you might be like, there is absolutely no way I'm going to try to factor on that. Great, graph it, get an answer, do synthetic, have at it. I'm a little quicker at factoring. I think I can factor on this. What 2 numbers multiply to negative 8 and add to 7? Let's start with that. 8 and to get x to the 6, I'm going to need to make these x to the 3rd, x cubed. Oh boy, I'm getting excited because I can factor both of these some more. We have a sum of perfect cubes and a difference of perfect cubes. So I can factor all of this down some more, which I'm going to do. Okay, quick question for you. What number cubed is 8? 2. So I'm just thinking about that as really a 2 cubed. So to factor this down, this is a throwback to chapter 1 when we did all that crazy factoring. We have our binomial, just take the cubes off, write small, and then you're going to square x. This is a throwback. Switch our sign from plus to minus. Multiply x and 2. Last sign's always a plus. And then I'm going to square the 2. That is just for the first factor. That's why I said very small. Because now I'm going to do this one. Okay, of course, to get 1, I know that's 1 cubed. So my first factor for this difference of perfect cubes is going to be x minus 1. I'm going to, of course, now square the x. I'm going to change the sign to plus. I'm going to multiply x and 1 together, 1x. I'm talking about x. Last sign's a plus, 1 squared. Okay. Well, I can tell you 2 of the answers right now pretty easily. Because if you solve this factor, you're going to get -2. That's easy. If I solve that one's pretty easy. I'm going to get 1. X equals 1. Okay, that's an easy one. So I've got 2 out of 6. 2 out of 6. 2 more answers coming from this. The other 2 answers coming from that. Okay. So, first off, would have graphing it helped us? Yes, it will hit the x-axis at -2 and 1. You could use synthetic division and work on it. It's going to take a lot of synthetic division. Because I'm like, oh God, I'm looking at this trinomial. Does this factor down more? Does anything multiply to 4 and add to -2? So I have to use quad form or complete the square. You know, I'm going to hit extend page here. Let's just get serious about it. I don't have my tall shoes on. Okay, so probably a good one would be completing the square because I can do half a 2 in my head. So that's what I'm going to do. So I'm going to have my x squared. I'm going to leave a blank for right now. We're going to subtract 4 over. So now I'm going to complete my square. Half of 2 is 1, squared is 1. Okay, the green one forces your trinomial to factor. Multiply to 1, add to -2. -4 plus 1, -3. So we're going to have some imaginary. As soon as I saw that -3, I'm like, ooh, eyes, here we go. Plus or minus, I'm going to make that I root 3. And I'm going to add 1 over. Okay. I have no idea where I'm going to fit the room for all the factors, but we'll deal with that in a minute. So I've got 1, 2, 3, 4 answers. 4 out of 6. Woo, okay. On this one. So the last 2 are coming out of this blue trinomial. Now again, you have the choice. You could complete the square or use quadratic formula. Just because I haven't done it today, I don't know, let's use quadratic formula just to practice that. You can complete the square if you want. I don't care. Don't erase it if you're completing the square. Keep it going. Keep it going. I'm just going to use quadratic formula to practice it. A, B, and C are all 1, so we really can't mess it up. X equals the opposite of B, or minus. B squared, 1 squared, minus 4 times A times C, all over 2A. 2 times 1. So just to practice, you can complete the square. You'll get the same thing. 1 minus 4, I've got -3 under there. And all I can really do is pop the I out for that. Do we want to cry yet? Do you have all 6 magical, beautiful answers? Are you out of room for the factors? Do you have room to write the factors? Okay. Let's write all the factors. I'm going to, yeah, I had to hit extend page. Okay, so x plus 2, my first factor to get the -2. Now, clearly I'm going to use plus or minus because we're way out of room, people, way out of room. So I'm going to use plus or minus for this. So I'm going to have x, +1, so -1, and then plus or minus I root 3. That's good stuff. Then I'm on the blue ones now. So 1 was our first blue answer. Its factor, of course, x minus 1. Now I'm on this last set of blue answers. And I don't care so much, but notice your problem doesn't have fractions in it. So I want to write this factor without a fraction in it. Remember, anytime you have a fraction, the denominator, the 2, just goes in front of x. Because you divide by 2, that's where you'll get your over 2. Then I've got minus 1, so I'm going to go plus 1. And then my plus or minus I root 3. I really have all 6 factors there. Just use the plus and minus. Hey, if you want to try to FOIL it all out and make sure you get the original problem back, hey, go for it. Go for it. Go for it. Go for it. All right, good stuff. Good stuff today. We got to use all the skills. Factoring, synthetic division, quadratic formula, completing the square. I don't know what more you could want in a math lesson, kids. I really don't. Home stretch. Find a polynomial degree 4. Okay, good stuff. Zeros I, negative I, 2, negative 2. We'll deal with that P of 3 equals 25 at the end. Now, we have done these. We have found the polynomials. So, meaning we are working backwards. There are the 4 answers. I need you to come up with the x to the 4th, the polynomial. So, I'm going to call my polynomial f of x. And I'm going to write my answers out as factors. So, to get plus I, positive I would need an x minus I. To get a negative I, I need an x plus I. To get 2x minus 2, and then to get negative 2x plus 2. All right, we now have the fun-filled job of FOILing this out. That is not a polynomial at all. Polynomial, sum of monomials. I need an x to the 4th plus da-da-da-da-da. Start FOILing. I'm going to do these first 2 together. Now, the nice thing is they're conjugates. The middles will cancel out, so I'm going to skip them. I'm going to do x and x. Skip, minus I squared. Okay. Same thing on the back 2. I'm going to skip the middles. They're conjugates. The middles cancel, so I'm just going to do x and x. Skip. Okay. Now, I squared is significant. Here's a throwback to chapter 1. What's I squared equal? Negative 1. If you ever forget that, remember it's on your graphing calculator above the decimal point. Punch it in. It will tell you. Okay, I squared is negative 1. So I have minus negative 1, really. I'm just going to rewrite this as plus 1. And I'm just going to finish FOILing this out. So x squared. Now, we're probably running out of room. Let's FOIL and do the middle terms and combine them in our heads. Because I'm going to have minus 4x squared plus 1x squared. And minus 4. Okay. And then, just when you thought you were done, we have this weirdo note. P of 3, they want it to equal 25. So you might be like, say what now? What am I supposed to do with this? Well, remember, P of x. So when you put x's 3 in, when you replace the x with the 3, they want it to equal out to 25. Okay, well, let's try to make this happen. So I'm going to put a 3 in for these x's, and let's see what we got. You can do it in your calculator. I'm just going to jot it down here. So 3 to the 4th. So math that out, of course. 3 squared, or 3 to the 4th, sorry, 3 to the 4th is 81. This is going to be 27. Minus 4. Punch it in, keep going. You end up with a grand total of what? 50. Now, here's the exciting math part to this. I promise you it's easy. They want it to equal 25. Okay, all right. If I want this to equal 25, big whoop. I'm just going to divide it by 2, which means then I'm going to go back and be fancy and divide all of that by 2. And I'm just going to write that out so it looks a little prettier because, you know, I like to be fancy about it. Meaning I'm just going to put it coefficient stat. I'm going to put it 1/2 x to the 4th. Do I care if you do this? No. If you put it all over 2, fine, but I like it to look nice. 3/2 x squared, and then 4 over 2, too. So you just have to do a little calculating to make that all pan out. So when I put 3 in, and you can test it if you're like, oh man, did I do it right? If you put 3 in here now, this blue one, it will equal out to 25 now instead of 50. That's a little scaling you got to do on it. All right, last problem of the day. We're probably ready, way ready. Okay, this you know, we've already talked about. I just threw it on here as a reminder for the upcoming last problem. So your conjugate zeros theorem, meaning complex number, your imaginaries. Do not forget that your imaginaries, the conjugates, work together. So I'm being dramatic because it's going to happen on our next problem. If they give you 5 plus 3i, you have to know 5 minus 3i is a 0. This last problem was nice. They gave you the plus or minus. This one not so nice. Find a polynomial degree 3. I'm like, wait a minute. Degree 3 means I need 3 zeros. I've got a half and I've got that. I only have 2, but you really have 3. Because if 3 minus I is a 0, its conjugate is also. So anytime you have imaginaries, it's always a pair. If they don't list one, you have to list it yourself. Okay, now what's the same thing as the very last problem? I'm going to write them as factors, and I'm going to FOIL. Okay, so my first 0 is a half. Now, I don't want fractions in my answer if I don't have to. So a half, I'm going to write that as factor form. I'm going to put it 2x minus 1. Because if you solve this, you add 1, divide by 2, you get a half. Then I'm going to do for this guy x minus 3 plus I. And then this one I'm going to do x minus 3 minus I. So there's the setup. Now, does it matter which 2 you FOIL together first? No, it doesn't, but I always have some pro tips for you, right? You might not think so. I'm going to start with the last 2. And you'll see why. So I'm going to do these 2 together first. Now, 2 ways you could do it. Trinomial times a trinomial. What's 3 times 3? 9. If you distribute all of that together, there's 9 terms. I don't want to write 9 terms. Plus, it's, Halloween and we're tired. The other thing, man, if you catch it, if you see it, that's difference of perfect squares. Because you have x minus 3, I, and negative I. You have difference of perfect squares. You can do a little shortcut action. If you do that together, you're going to have x minus 3 squared. Yes, I know I have to FOIL that out, but I can FOIL that in my head. Skip the middle, minus I squared. You can do all 9, 3 times 3, and get all 9. I don't care, you'll get the same thing. Just trying to show you a little shortcut here, if you catch it. Okay. Now, I can FOIL this in my head. Minus 3, minus 6 in the middle. So x minus 3 quantity squared FOILs out to this. Now, we already saw this earlier. Minus I squared is negative 1, minus negative 1. And I'm going to combo that 9 and 1 together and make it a 10. I mean, the perfect square thing does save you a little bit of time, but let's just be honest, does this still kind of suck? It does, because we still have to distribute all of this together. Yeah. Let me scroll it up so I'm not clear at the bottom here. I gotta get some taller shoes. Okay, so I'm gonna do 2x and x squared, 2x and 6x, 2x and 10. Having fun. So much fun. Now I'm going to take negative 1 through. Minus x squared plus 6x, and then minus 10. Okay, let's combine the like terms, put it in order, highest exponent to the lowest, how I like it. X cube's the only cube we got. Now I'm looking at my squares. Minus 12 minus 1, negative 13. 20x plus 6x, let's go 26. And core negative 10, no like terms to combine with. Hanging in the bag. Wasn't that so fun? God, I love this chapter. Yes. Any questions on that? The looks on your faces is always super crazy. Hey, tomorrow we have like a graphing section, which isn't too bad because you can look